Good morning, friends. In the earlier video we saw that we have same SRGB value all across the network on all the nodes. It makes the operational and troubleshooting task very easy. And if you remember those challenges we had with the LDP and RSVP where label value were different on each and every hop, and while troubleshooting we need to remember that label values on each and every hop. But that is the advantage with the segment routing. Based on index value and SRGB value, label will be same all across the network. But if we change the SRGB value on any particular node or on the few nodes, it doesn't mean segment routing won't work. It will work, but again you will have some operational and troubleshooting challenges. So let's deep dive what are those exactly. So in this scenario where we have same SRGB value all across the network, so let's say if we need to reach from P1 to P6, we got the IPv4 packet. We will push the 16006 because SRGB value on P3 is 16000, that is by default. So it is going to calculate that value 16006. Then again P4 has same SRGB value. So based on that one, label comes for the P6 destination, it's a 16006, and then P4 is directly connected to P6, so here it will be penultimate hop popping and IPv4 packet will reach to the PE6. But let's see scenario where we have configured the different SRGB value on PE3. So before that, let's check few outputs on the working scenario. So if we trace route to the destination, you can see here we have same label on all nodes. So that's become very easy to troubleshoot. And if we check the database, let's check just SRGB value. So you can see that the same SRGB value for the IPv4 and IPv6. I1 is for IPv4, V1 is for the V6, and we have same range on all the nodes 16000 to 23999. So total labels range we have is 8000. If we check this safe value for 6, so we have two paths toward the R6, that is ECMP path, but on the both path we will push the same prefix. If we check the forwarding tables, you can see that we are pushing the same value, and same will be the case on the P3. So here we are pushing the 16006. Incoming label is 16006, outgoing label is also 16006, which is going towards the R4. So let's check on the R4. So it is the implicit null, and if you see here, this is the repair path, that is I have configured TILFA on this node. So we will discuss those in the subsequent videos. So this is the implicit null which is going to forward toward the PE6. So our local label which we are receiving the packet 16006 from the PE3, we are going to pop it implicit null and we are going to forward it toward the 6. This is the backup path. This is how it works, that on based on the SRGB value on each and every hop, the label value is going to calculate for that particular prefix or for that destination. So let us see if we what happens if we change it on the P3 box. We will change the global block, let's say 18,000 to 20K. So once we are done with that one, we need to reload the box. I'll reload the box and it may take time, so I'll come back after 5 to 10 minutes. So if you check the show as database, SRGB value, so you can see that on all node it is 16,000, but on the P3 box it is 18,000. And if you check the trace route, so PE1 is attaching the 18,006 label and sending towards the P3, that is the incoming label for P3. Then P3 will swap it with 16,006 and he will forward it to the P4. P4 is directly connected to P6, so he will have the implicit null label. If you check the safe value, so here you can see towards this particular path it is pushing the 18,006 label. But one of the challenge here I see that this could be due to the new enhancement which is happening on for the segment routing on in each and every release. So if I check this safe entry for the three P3 routers, I don't see any label value assigned it with. So there could be enhancement happening and Cisco want us to have same SRGB value all across the network. So this could be the effect of that one. I need to check more on this one. So if we can verify it with the P3, show SIP 6666. Here you can see that our local label for P3 is 18,006 and he will going to swap it with the 16,006. This is the local label 18,006 based on the SRGB value for P3. This is going to be outgoing value, and by swapping this label he is going to forward it towards the P4. So let's see, let's verify on the P4. If we see the SAP entry here, P4 is going to receive it 16,006 label and he will do the implicit null. If we check the show MPLS forwarding table, here is the entry, here is the incoming label and here is the implicit null is the outgoing label. This is the TILF path, we can ignore it. So if you see on this diagram, if packet hits IPv4 packet hits on the PE1, he is going to push the 18,006 label, so he will calculate the SRGB value 18,000 plus 6 for the P6 destination. So labels become 18,006. So this is the outgoing label for him, and the 18,006 is the incoming label for P3. So once packet received on P3, he is going to swap it with the 16,006. So outgoing label for P3 is 16,006 and incoming label for P4 is 16,006, which is local label for her P4, and he will do the penultimate hop popping and he is going to forward it to the PE6. That's it from my side. Thank you for watching.